So now let me show you how to do this step by step. Okay, to give a big picture, here I have a component, it's a PMOS, and it's in schematic form in Virtuoso, and here is equivalent to Virtuoso layout. And so on the schematic side, I will simply use dynamic link, and then I insert this schematic into here. So this guy's sub-circuit is this guy, okay? So then I leave it there. And then on the layout side, I would use Express T-cell and bring this one to here. And if I didn't use Express T-cell, if I just directly open this layout in ADS, I will not see this portion. This guy, this PMOS is a T-cell. So I just see this one is empty here. Okay, so I use Express T-cell, you see a screenshot of this T-cell. Okay, then after that, inside ADS, under ADS library, which is the equivalent, so this guy's library as well. And I create a new layout, and I insert this guy in here. And then for this library, this is the ADS library. So on this ADS library, I'm going to copy this guy's technology over, right? So that I can modify it, okay? And I would add my heat layer name, heat layers here, and I can add my heat source name here as well. And then after that, then they're equivalent, right? So after that, I can just run the top level EThermal simulation. Okay, now let me give you more details. So I hope that you guys understand this. This is what I was saying in the block diagram there, but right now just give it more visual, right? Okay, starting from the Cadence schematic and the layout, okay, for one component. And it's under the Cadence library called the Dynamic Link ETH. Okay, so the cell name is IMOS. And then I do, on the Cadence schematic layout, I say Tools, Express T-cell Manager. And this one shows up. And it will pop up this PMOS. Usually you say save cache, and then you see this PMOS comes out. Okay, so that means that in this entire layout, I only have this one thing that is a T-cell, which is a PMOS. Then I say save cache, apply OK. And after that, I have this .express T-cells directory generated right at where I started Virtuoso. Now, on the ADS side, I'm going to go launch ADS dynamic link. And so the ADS is started. Once I start the ADS, I'm going to create an ADS workspace without any technology. This is by default, it's like that way, right? You don't need to create any technology. And after that, you go to this design kit, manage libraries in the ADS main window, and you're going to add two libraries, right? One is the Cadence design library, which is what I showed you, Dynamic Link ETH. Another one, I need to enter this GPDK, which is the reference of this one. So on the Cadence side, this guy is attached technology, right? And here I just added this one in. Okay, so once I get this one in, I need to do this. So this is my ADS library. And then for the ADS library, I would reference to this GPDK. So I want to make a point, right? On ADS side, this GPDK, even though, you know, for the Cadence side, this GPDK is attached. And on ADS side, you could make it either attached or you can make it a reference as well. The only benefit that I do reference is because it also allows me to add some other reference libraries, right? If I just attach it, I won't add something else. But here I also want to add this schematic layers for my library, right? So I just use the reference. And for this EThermal, you need 3 files. And I think Jason mentioned to you before. This is the heat layer name that I want to have. I'm going to add later on. Then this channel is defined in the tickle.tcl, telling me what the property is. So this is the thermal kind of information. This is a kind of like a physical layout layer inside my layout. Okay, so this is the mapping. So we have the 3 files need to be stored inside a folder called thermal. Okay, so once you put all of the 3 into the thermal, and then one step you need to do is that you need to tell the library, which is the dynamic link EThermal _test_live. Right click on it, you say configure library. And from here, you're going to tell him where that thermal folder, that has all the 3 files, is located. Okay, you just tell this guy. And if you tell this guy where that's located, and later on in the EThermal, the UI, you will be able to find the tickle file right away. Okay, so this is the step you need to do. I just put all the logistics things all together here. Okay, and so the last thing that you need to do is that, this GPDK, I copied it from the Cadence GPDK, right? Cadence library GPDK there, and then copy over to this guy here. And after that, you'll see under this library, you have all this Cadence GPDK information here. And then you can also add the heat layer. So this is for you to draw the heat layer shape and add a heat source name there on this layer. All right. So I'm just talking about using dynamic link fire up the ADS, and inside ADS, I need to take care of some of the EThermal, those kind of technology things, right? So I did that. And now, remember at the very beginning, I did the express T cell from your layout. And then that layout created the .express P cells. And right now, in this prompt, this is where I started my virtuoso. Okay, then I say copy -R, it's a directory, right? .express P cells, and put it right underneath this ADS workspace. And then that's all. And after that, you go open your ADS, right? You just created this workspace. And so here, this guy is the virtuoso library, right? Where it has a TMOS, ITMOS, everything, right? And this one here is my ADS library. It comes with the, use the name of the workspace, right? So this is the ADS library. And now this, if you open this ITMOS, it looks like this. Okay, it has included that express P cell. Now this is that intermediate layout that I was talking about. Okay, so you are generated under the ADS workspace, and I just call it IPMOS_IDF. And from here, I create this layout and insert this guy into this layout. And then I use the component promote instance. I just grab the pin names, this name from the bottom to the top, and automatically add in X1. X1 is the instance name, right, of the cell. Now I go back to this schematic here. I need to set this guy's equivalent schematic. So what I did is that from here, I insert the TMOS from Cadence over here. So if I push this guy here, it would be the TMOS on Cadence side, the schematic. So after that, right, I can just, insert this sub-circuit to here. And then I can run a simulation, use a sweep, right? Use a sweep, then I can find, okay, I want to bias my things right here, right? Saying, okay, I can run the BC simulation, not a big deal, just on the schematic. But right now, I want to run the EThermal. That means I need to do a electrical and a thermal simulator co-sim. So in order to do that, I needed to take care of my heat layers and heat source names. And right now, I want to show you how do I name my heat source. First, what you do is that you add a variable. It's called underscore debug underscore pval equals to 1. You do this first, and after you just run the DC. There's no thermal here. Just run the DC simulation. After that, you go to your workspace under the data directory. There's a file called pval-dc.pval. And from here, you see there's a name here, right? It's called x0.x1.pm0.pmos1, okay? And so based on this name, this is like the power dissipation, right? Because for the DC, for circuit simulation, I can only come out with this power dissipation. And from here, based on this name, you are going to name your heat source names, okay? So let's take a quick look, right? See this guy, which is this guy is this guy. Let me go back here. It's this guy, right? So this guy has an instance name of X0, okay? And then you push into it, and this guy has an instance name of X1. Let me just go back to show you. Here, right? This is X1. So you have a talk X0, and then you have X1, right? Now you understand what that X0.X1 means, right? And now what's this? Okay, let's go back here. So what that one is that, the PMOS itself has the instance name of a PMOS, okay? And it has a model called a PMOS1. So if, let's say, you want to name, if I have the permission to change anything on the Cadence side, right? Let's say, I could, I could just do this. I could add on this level, and I only need to call myself pm0.pmos. Just to give myself the instance name and my model name. Be done with it, right? So this is one way to name the heat source name, okay? And the other way is you can go up here, because for me, right, I can't change this guy. So I use this approach. So this is the ADS layout. Okay, and then this is the ADS schematic. So I say, okay, my schematic got an instance name of X1. I would just put X1 here. And then underneath is this PMOS instance name. And then I go X1.pm0, and then the model name PMOS1. Then that's it. Okay, so you named this heat source. So this heat source, did you see the yellow one? This yellow one means that I need to draw the shape of telling it where my heat source is like. How big is it? Which layer is it? Things like that, right? In this case, this guy is in the layer called heat underscore fed, right? And then on the same layer, I also add a name here. Just say add text and add x1.pm0.pmos1. And so this is my heat fed and PMOS1. And after I'm done with this, right, you can go File, Recent Workspaces, and then load this workspace. After you copy that .express T cells to ADS, you need to use this method to reopen your workspace, and then that express T cell will show up. Okay, otherwise it still, chances are still doesn't. On the circuit simulator, you double click on that. You will see this TCL is right under here. Sometimes you see it's empty, right? Here it's all empty. The reason for that is that you didn't do the configuration. Remember at the very beginning when I was sorting out all those logistic stuff, I was configuring that ADS library and go to simulation and say, here is my thermal folder path. Okay, after I configure that, and this one will show up. Okay, now I can add this electrical thermal. Okay, I was saying I double click on this one here. This one will come up, and then make sure you have this file there. Okay, then after that, you're going to run the simulation, but make sure at this point you uncheck this one, because this one is for me to figure out what my power dissipation, those instance names are, right? And right now I don't need that, to just uncheck it. So after you finish the simulation, if the simulation runs, right, that means, yeah, you did a good job of configuring your names. But let's say you somehow, you made a mistake. You call it X2 or whatever. So it didn't work. And at that time, you can come over to this ADS workspace there is a simulation directory. Then you go to the library name, go to the cell name, go to the view name. Then there's an ETH folder. And then you open this ETH folder. There are two files. One is a pval, one is a tval. Okay, so the pval, it will tell you the power dissipation. The tval will tell you the temperature and the power as well. Okay, so here's the power. Here's power. And so these two names, they need to match. Okay, and sometimes your thermal simulation doesn't run, and then you just come over here. Maybe you made a mistake, right? If they are not matching, and then try to make it match. So this is about how to name heat source names. Okay, and then if I just run the simulation the way it is, right? This guy pretty hot because it's just very small. And then I added the two metals on the metal one here, metal one. And after that, you run the simulation, and then you see this thermal plot. Okay. And here's what I was talking about, right? Let's say I just configured this one. And right now, because I don't have another key, so I'm just imitating the situation by entering this multiple times. So here's my ADS component now, and here's my layout equivalent, right? You can hook this one up and hook this one up, and then you can go on and run it with thermal.